We'll be happy. And I think I should give Cassandra a boff there for complimenting you.
Wow.
That's an interesting way of
No.
No, it was very sincere.
No, it was because you should get the boff for reminding me to record. Here, let's pass it over.
I actually don't want to fund it.
Okay.
Can I have it?
I'll keep it here right now. All right, so let's look at example 1 here. What's the probability of getting 2 tails on a toss of 2 coins? Okay. So what's the probability of getting that? So 2 tails. So if I flip a coin, I can have 2 coins and flip them both, or flip a coin, flip a coin. Okay, you said a half and a half, right? So a half times a half is 1/4. Because when you multiply fractions, you multiply across. 1 times 1, 2 times 2. 25%. Or we could look at it. What's our different options we could get? We can get a head-head. We can get a head and then a tails. We can get a tails, then a heads, or we can go tails, and then a tails. Right?
You want us to write this?
Yeah. So our option here is this. 1 out of 4 options, right? We have 4 options, but one of us is, it's 2 tails. Good. Now, if we think about this event, right? If we think about this happening, is this a independent or dependent event? I'll agree with independent, but why is it independent? Good job, Hannah. Is that what you're going to say?
Yeah.
Good. I always feel bad. Hannah puts her hand up by weight.
But you stare at me, so I just
Okay. No, because the 1 coin, like if I have 2 coins.
Getting 2 tails is dependent on getting 1 tail.
No, but if it's at once, right? 2 tails. But either way, right? Getting them, like if I have 2 coins here, the spin of, like what this coin happens.
Yeah, it's not dependent on the other thing.
Correct. Yeah. Right? And that's why it's 1 out of 4 is like, you're right. Like getting it correct depends on the other one, but each event is independent of the other. Okay? Okay, so if we fill in this here, right? T1, so we can use the AND formula here, correct? Now, because these are mutually exclusive, we don't need to add that intersection of them, right? Like the flip in here, flip here, they're mutually exclusive. One's not going to depend on the other. So we can use the AND formula. So the intersection, boom, 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 is, so if T1 is the first flip, right? The probability of the first flip happening, getting a tail, is 1 out of 2. The probability of getting the second flip is 1 out of 2, which would equal 1 over 4, which we kind of did informally up here, correct? But now we're putting it into, so what's the probability of getting a tails on one and a tails on the other? Right? So because they're independent, we can use the AND formula. And then we could write it down here as well. And the key here is A and B must be what? What must they be? Yeah, or independent, right? Oh, it's funny, on all those notes, I just realized that upside down U actually is written with an N. This here, I just realized for the first time, was like that. I've always seen what I've wanted to see. That's how I got fired from the M&M factory. Now that's a dad joke.
Isn't today like a year of quarantine now?
I think so, yeah. All right.
13.
March 13th, yeah.
Okay, here's what I want you to do.
This one came out a year ago today, though.
So, here's what I want you to do first. Okay? You roll a red die and a green die. Okay? I want you to make, oh my god, it's a big guy. 2, 3, 4, 5, 6. I want you to fill in that chart for me. Okay? So this is my green die down here. This is my red die here. So if I roll a 1 and a 1, I will get a 2. If I roll a 1 and a 2, I'll get a 3. Pardon? Okay. This might be a good hint to make sure that you know how to do this for this afternoon.
Like how to make one of these cards or just question?
Yes.
Man of many words, okay.
Did you keep those one of these charts?
No. I was going to.
You're not anymore.
I might. But seeing there might be a question on the quiz this afternoon that has you build one. Although I just realized you have an open book quiz, so you could just copy it off of this.
You also gave us one on the handout from yesterday.
This is not
Yeah, that too, yeah. Well, screw y'all then. I'm filling in my chart, and I'm ruining your fun.
I don't understand.
What time is
Oops.
So did I. I watched Iron Man 2 last night. I'm not even joking.
Did you?
Oh,
That's
it's really good. Yeah.
Such a good
First one's good, but I actually like that one better.
Iron Man 3's except for the kids scene.
Okay, you know the little kid that Iron Man saved in Iron Man 2 that's going to get killed by the giant asteroid robot?
Running like this.
Yeah. They retconned that. That's Peter Parker. They didn't obviously intend that originally, but they just retconned it.
Okay. So let's answer A first. Okay. We're looking for a green 4 and a red 3. Okay. So first things first. Is the event independent, yes or no? Is rolling a green 4 and a red 3 independent of each other? Yes. Okay. So that's yes. So therefore we can use our independent formula, right? The and formula here for this. So probability of, think about like a green 4 and a green 3 occur, sorry, red 3. Equals the probability of a green 4 times the probability of a red 3. Now what's the probability of getting a green 4? Just think about just the green dice. What's the probability of getting a green 4? Colin? 1 out of 6, right? And what's the probability of getting a red 3? 1 and 6. Well, just look at, don't worry about this chart yet, but just let's probably get it, like just look at the color here. Yeah, that's the sum, right? Those are the sums. These are just the numbers, right? So we times those together, we get 1 over 36. That's our answer.
So what does that mean?
Well,
There's
1 out of 36 chances I roll those 2 dice, I'm going to get a red 4 and a green 4 and a red 3.
so only one time
Yeah, and if you look at the chart, it makes sense.
because it's 36.
Hmm?
Because it's like 36.
Yeah, but if I look at the chart here, where's the chances of getting a green 4 and a red 3 only occur right there, right? Green 4, red 3. They only occur once within that space of 36. Okay, does that make sense? Okay, so let's take a look at the second one. What's the probability of getting a green 2 and a sum of 3? Is that independent or dependent? Is that independent? No, because it depends on the other dice, right? Like getting a green, what was it? A green 2 is independent, but to get a sum of 3 depends on the red, right? So we're going to go back to our conditional probability one. Okay, we have 2 options that go through this. So I'll write this out here. The probability of the intersection of a green 2 and a sum of 3. I'm going to write it down and then I'll explain it. No, that's a line. That's the given. Correct. So S equals sum, and the G would equal green.
How did you put the S on that side?
It doesn't matter.
Oh,
We can do either one. Okay, so this is reading, right? So what's the intersection of a green 2 intersect with a sum of 3? So the sum of 3 given that we have a green 2, okay, times the probability of the sum of 3, okay? So first things first, let's look up here at our chart. I'm going to write this one in first. What's the probability up here of getting a sum of 3? Two over 36. Good. 2 over 36. What's the probability of having a sum of 3, a green 2 and a sum of 3? 1 over, no, 1 over 2, right? Because we have 2 3s here, correct? We have 2 sums of 3s. How many have a green 2? Just this one. Ça va?
can you explain that one more time?
Okay. A sum of 3 given we have a green 2. Okay, or a sum of 2 given we have a sum of 3. Right? Of the sums of 3s that we have, how many of those also have what's the probability one of those has a green 2? Well, there's one of those, right, over 2 options. Yes?
So you think of it as like a sideways fraction?
Explain what you mean by sideways. Yeah. I guess that's right. Let's check it out. I never thought about that.
Yeah?
Let's see how it works out.
Well, because you have your green.
Yeah.
And then your 2. And you have 1 green over
Yeah.
2.
Yeah. Let me double check that.
Okay.
You blew my mind there, so I can't. I never saw that. In a good way. All right. So this equals. Well, if you plug that in your calculator, you get 1 over 36. Because these will cancel out to 1 and 1, right? Then it's going to equal that. Okay? The other way you can look at this, I'm going to do this way over here, but we're going to do this one again. Okay? The probability of green 2 intersection with sum of 3. But then we can reverse those. We can reverse our thoughts here. Okay? Probability of sum of 3, given we have a green 2, times the probability of getting a green 2. I'll wait till everyone's done that line before I start going forward again. Okay, what's the probability, if we take a look at our big chart up here, what's the probability of having a green 2 in our chart here? All these ones have a green 2. So that's 6 out of 36 altogether. Okay? Then, what's probably having a green 2? You know you have a green 2, so I'm going to circle the green 2s. Okay? Right? Here's our green 2s again. How many of those have a sum of 3? 1. So the probability there is 1 over 6, because we had 6 different options, right? So that equals 1 over 36 again, when we do the multiplication. These two would just cancel out, 1 and 1.
How'd you get the 6 over here?
Good. Yeah.
Wait, how'd you get 36 on the first time you did it?
36 is on the numbers.
Yeah, but.
This one?
Yeah, why can't you go from the 2 to a 1?
Oh, because when you multiply these, if you kind of do it manually, the 2 on the bottom here will cancel out that 2 on the top.
So it becomes 1.
Yeah. Like 2 divided by 2 would equal 1. And if you plug it in your calculator, you get the same thing.
Mr. O, sorry, in between the 5, 3 and the G2, is that a 1 or what is that? Like,
This?
yeah,
This is our given line,
okay.
right?
5G.
Just a line, okay.
Yeah. Now the other way is we could just look at the sample space in this question, and we could look at how many of these sums of 3 have a green 2? 1, right? So your answer is 1 over 36. That's just looking at the chart. That's the easiest way to do it, but sometimes you don't have these options along those lines.
Sorry,
Okay.
what was that?
The other way to do it is we could just look at our sample space. So we made that area, that's our sample space, right? And we could look and say, okay, we need a green 2 and a sum of 3. Green 2, how many sums of 3 do we have? 1. Out of how many different options do we have? 36.
Did we get enough for that?
No. Right? All right, let's go to this one. Okay, A bag contains 1 red marble and 2 white marbles. 1 marble is drawn, its colors noted, and then replaced. A second draw is made. What's the probability a white marble you'll get a white marble of both times? Okay, independent or dependent? We're taking it out, we're looking at it, we're putting it back in, then we're taking it out again. Mia? No.
Because in order to draw 2, it's dependent on the fact that you already drew 1.
No, we took it out, we looked at it, but then we replaced it.
Okay.
So take a look, like independent ones have the same probability with each occurrence. Does that make sense? So if I, like here we go, I have like 3 pencils and 2 markers, correct? If I mix them up and pull one, right, and then I note it, then I put it back in, the probability is still the same after I put it back in. I still have 3 and 2. So that's independent because they're independent. Like each one has the exact same. But if I take it out, right, and I go like this, and then I pull another one, my next draw, my next selection has a different probability. Does that make sense? So if it's same probability every time, we're independent. If the probability changes each time, then it's dependent. Okay? Does that make it clear for people? All right. Drop the pen. So we have independent here. So we can use our formula, right? And we can say like the probability of like white on the first draw and white on the second draw is the probability of white, like pulling a white, times the probability of pulling another white. Correct. So probability of pulling a white, since we have 1 red and 2 white, is going to be 2/3 times 2/3. Because each of those probabilities will be the same. Which equals 4/9. No, bottom and top. So think about it like as a divide, right?
The other ones you did 1.
Correct. Because one was on the top, one was on the bottom.
Oh.
Right? If you think about it like this, I'll make one up for you. 2 times 9 times. Right? So if I think about it like this, if I take away that and make it just one big one, like this, 4 divided by 2, that's how you can't cancel them out. Right? Because it's kind of like a divide. But since these, you can't divide these, you can't divide 2 by 3 evenly. Okay? At worst, if you just want to do it in your calculator, that's fine as well. Okay? So there's your probability there. Now the same example, but the marble is not replaced. So we pull the first marble, right? And we set it aside, and then we pull the next marble. That one's dependent, right? So we have to use our conditional, right? Because the second pick is conditional on the first pick.
Now, question.
Yep.
Is this like the goat door where it's like after you pull the white marble, now the red marble is like 2/3 chance of being pulled?
No, because your percentage of wins changes fully because you get to reselect. Does that make sense? So the probability of W2, W1 times probability of W1. So what's the probability to draw that first white one? 2 out of 3. Good. Then what's the probability of drawing the second white one given you've already drawn the first white one? 1 out of 2. Right? Because there's only 2 marbles left, right? And one of them's white. And if you plug that in your calculator, I answered 1/3. Ça va? And I'm just concentrating on not looking at Cassandra after she called. Well, you do good. You do a good job. No, he's watching you. Oh, sorry. 1/3. Okay. So, what's the probability of selecting exactly 1 marble when 2 marbles are drawn? So how could we select 1 white marble? There's 2 ways we could do it. What could be our selection pattern to select 1 white marble? We could select red and white, correct? Or we could select white and red. Pardon? Correct. So you want to do indirect?
What do you want to do?
So, okay, slow down.
Well, there's 3 marbles, right? 2 are white and 1's red.
Right.
You could pull a red and a white and a red, or a white and a white.
Correct, but I want to know the probability
Selecting one white.
exactly 1 white marble when I select 2.
Yeah, but even if you're calculating for the probability of selecting only 1 white, then you have to include the probability of selecting 2 whites.
No.
If the word exactly wasn't there, would you do white and white?
But you could still do.
I
Well-
understand though exactly 1 white marble when drawing 2 marbles.
So I want to select.
What
How's that?
Throwing 3 marbles?
There's 3 marbles, but I want to select 2 of them out, right? What's the probability of getting 1 white and 1 red?
Are we assuming that
1 over 3 times 1 over 3 times 1 over 2.
Not quite. Let's work it through here. Okay.
When we do like the heads and tails question, we still account for the fact that like if we want to flip heads and tails, we still account for the fact that we could possibly flip 2 heads and 2 tails.
Correct, but we don't.
Why wouldn't we
It'd be
account
1
for
over
that?
3
But we wouldn't include those in our calculation because that's not what we want. Right? We see it. Like if we go back to the very first example, right? This one? We see those, but our probability is just this.
It's just confusing because it's saying to pull a white one, and even if you're pulling 2, you're still pulling 1.
No, exactly 1 white one.
Yeah, but it's pull 2 marbles.
I want exactly 1. I only want 1 white.
But you're
Yeah, but
pulling
there's
2
still the
marbles.
But I'm pulling 2 marbles. I agree.
Oh, wait. Would it be 1 over 3 times 2 over 2?
Let's work out the answer here.
If you pull out those 2, wouldn't it just be 100% because you're getting the 1 marble anyways?
No, what's that?
Regardless, you're gonna get a white marble.
If you pull a red marble, you're gonna get a white marble.
Correct. But if I pull a white marble first,
You have a chance to
you either get a red,
You still
a red,
didn't
then
pull
white,
the
or
other
white,
way.
then
correct.
But that's still 100%.
Alright.
No, I want exactly 1 white.
Are you gonna eat that one in, Frank?
Yeah, but
Or-
it's a chance that like you could pull 2 whites.
I agree.
So why are we accounting for that?
Because that's not the question to account for. I'm confused. But we don't need to, like, we can see it, but we don't need to count on our probability.
Yeah, it's still a chance that you're gonna
Correct. But that's going to be the opposite end of my 1. Right? Well, one is like all possibilities, correct? But we're going to, so 1 is like, this is 1, right? From here to here is 1. Does that make sense? Here's all my possibilities. You're right. There is a chance I get white and white, right? But there's a chance I get red and white or white and red. Those are like my three options I could get. I want the probability of this space here. All right, so I'm going to leave this space out. You're right. But there's two ways we could work this through. Okay? So the two ways we could work this through are we could find the probability of these two occurring and add them together. Okay? So if I were to write the formula, right, it would be the okay. White one, I have to build my formula backwards. That's how my mind works. Probability of red, knowing that I picked the white one. Okay? Does that make sense what I just did there? So I'm going to pick the white one first. Then what's the probability of picking a red one knowing that I picked the white one? Okay? Then the other one I would do, I'd pick a red first. And then what's the probability of picking a red plus the probability of picking a white given I picked a red. Is that going to work out for me? Yeah. Okay. Do you guys see what I just did? Does this make sense? So on this side over here, I said I'm going to pick a white one first, right? Then what's the probability of picking a red one given that I got a white one first? So I went, this side here is W, then R. This side here is R, and then W. So I pick a red, then a white. Okay? So if I work this side first here, Megan, what's my probability of picking a white right off the bat? 2/3. Then what's my probability of picking a red, knowing that I already picked a white one? 1/2. Good. Over here, what's my probability of picking a red right off the bat? 1/3. And that's what's my probability of picking a white, knowing that I picked a red right away? 2/2.
Sure, did you mean to put ones beside the R in the formula?
No, because there's only one red.
Oh, okay.
That's why I didn't. I could pick it, but there's only one red, so that's my only option. Okay? So this is going to equal 1/3. That's going to equal 1/3. And together they're going to equal 2/3. Now here's my question. I'll let everyone write that down first.
So, I got 5/9.
How'd you get 5/9? These two cancel, right?
I'm just doing my calculator. I know what I did.
Wait till I ask this question, and then I'll answer yours. Okay, that's one way of doing it. What's another way of doing this? Not quite. I like your thinking. Not independently, but
Couldn't you just like you did it how where you showed as many options as you had because it's such a low number and you can be like, well, three options, I'm gonna get it.
yeah. Oops. So that's like the three options we're going to pull, correct? And realistically, this would be the one. But let's go about your technique, but in a mathematical form. We could do it indirectly, right? So if we want to know what the probability of getting these two are, we just take off the probability of getting W and W, right? Which we already worked out. So the probability of not getting two whites would be 1 minus the probability of getting two whites. And what was the probability of getting two whites? 1/3 from the previous page. Right? That'd be 2/3. Because if we went back, if you look back one page on example 4, we figured out the probability of getting 2 whites. I think that's how you figured it out in your head the first time.
My calculator does when I do like a fraction, it doesn't do it because I have a.
Let me see. Press. Show me. Go 1/3.
Why did you put the 1 there though?
Yeah, that's a third. Yeah, that's a fraction. Yours doesn't go on top, but it's still a fraction.
It's still a fraction.
Yeah.
So if I move one-
Because I'm doing indirectly. So this is 100% chance, right? What's my 100% chance minus my probability that I'm missing, right? So I said, what's 1 minus this probability will give me
What would the 100% chance be equivalent to? Like, what is it?
all 3 options, all the options. Okay?
It's 3 over 3. Okay.
Yeah, in that sense, yeah. Okay? How do we feel about that? Thumbs up? Okay. All right, so I'll give you some time to do some work. Okay? You'll have a little bit of homework today. Like, I'll give you 20 minutes of work right now, but then we'll start our next lesson at around... No, there's not a lot of work. You'll have time. How would I say this? You won't get done all this homework right now. And you won't get done all your second lesson homework before lunch. But the quiz should not take you an hour and 20 minutes. So you have time after you do your quiz to finish off your homework.
How many questions is the quiz?
Well, 3, but they're not really 3 questions. Because question 1 goes to like F,
Oh, okay.
right? And then there's like 2 and 3.
And then 2 and 3 are marked, right? And then the other ones, you said the second half of that's marked.
Oh, I'll mark it all.
All of them.
I'll be nice to you.